All right, we're going to do 8.3 operations with radical expressions part 1 notes. And what we're going to be looking at today is we're going to be looking at how to add, subtract, and multiply radical expressions. These are pretty simple. Biggest thing is especially when adding and subtracting right here. When we add or subtract radical expressions, basically what we're doing is we are combining like terms. Okay. And the radicals are like terms, combining. I think I spelled that right. Yep, like terms. And we did this before. Remember, if say we have 2x plus 3x, well, we get 5x. Or if we have 2x plus 4y plus 3x, well, the x's combined together to give us 5x, and then we just add the y on. It's the same thing with radicals, okay? So like if you have like 2 root 2 plus 5 root 2, well, now you have 7 root 2, right? So how when I do these, I always imagine the radical as a variable. So let's take a look at some examples here. So if I wanted to simplify this, if I have root 6 plus 5 root 6, well, there's no number in front of this root 6. It's just like x. So if like I have x plus 5x, well, in front of the x, there's this imaginary 1. So if it helps you out and you want to write this imaginary 1 right here, you can do that. And so when we do that, we just take the coefficients. So we have the 1 and the 5. We add those together. And then our radicals stay the same. So this answer, 1 root 6 plus 5 root 6 is just 6 root 6. Okay? So when we're combining these, we look at the coefficients in front of the radicals and we combine those together. And then the radicals don't change, just like the variables. 2x plus 3x is 5x, right? It's not, 2x plus 3x is not 5x squared. We don't do anything with the variables. We don't do anything with the radicals. So let's take a look at this one right here. Let's change color. Let's use this cool blue right here. We have negative 2 root 2 plus 3 root 2 minus 6 root 2. Well, they're all a root 2. So all these coefficients right here, negative 2, positive 3, negative 6, we're just going to combine those together. All right. So we get negative 2 plus 3. Negative 2 plus 3 is going to be 1. Right. So this becomes 1 root 2 minus 6 root 2. And now we have 1 minus 6, so we have negative 5 root 2. This is my answer. That's all you're doing when you're simplifying radicals, okay? You just look at the coefficients. It's just like combining like terms when you dealt with variables. If they're the same variable, combine them together. All right, next. We have 5 root 3 minus root 5 plus 2 root 3 plus 4 root 5. Okay, so this one we have different ones. And again, if you want to, I like to use colors. So you can say, hey, this one's going to be blue, anything with a root 3. All right, I'm going to include the plus 2. This is a root 3, so this is going to be blue. All right, let's get a different color. Let's go red. Okay, so this is a root 5. I'm going to include this minus sign with this. And this is a root 5. I'm going to include the plus 4 with this root 5. And now we just combine colors. Right? So we have a 5 root 3 plus 2 root 3. Well, that's going to be 7 root 3. And then we have a negative root 5, so it's negative 1, plus 4 is going to give us a plus 3 root 5. And that's our final answer. Okay? We just combine like terms, right? This is just like if, say, you had 5x minus y plus 2x plus 4y. The y's go together, the x's go together. Same thing here. The root 3's go together and the root 5's go together. Right? Now this one right here, we got 3 root 8 minus 2 root 2 plus 5 root 6 minus 9 root 6. Well, we take a look here. We can at least notice that these ones right here, these are like terms. So if I combine these together, I will get negative 4 root 6. Well, these ones right here, the root 8 and the root 2, they're not like terms. So initially we'd be like, oh, we can't combine them. But if you remember, we can split this root 8. We can split this up into 3 times the square root of 4 times 2. Because square root of 4 is 2. The 4 can escape. So now we have 3 times 2 root 2, which gives us 6 root 2. So this 3 root 8 turned into 6 root 2. Now we have 6 root 2 minus 2 root 2. 6 minus 2 is 4. So we have 4 root 2. So even though initially you may say, hey, look, we only have one set of like terms. Well, really, actually, no, we had 2 because we can split that root 8. So make sure you remember to really look to see if you can split one up, if you can simplify the radical, right? Like we did here. We took the root 8 and we turned it into 2 root 2. Well, you got to multiply by the coefficient there. Okay, so there's some on your owns on here. If you want to do the on your owns, you can. Otherwise, we're going to move on to the next thing. Next, multiplying radical expressions. What you do is when you multiply these, you multiply the coefficients, right, which are the numbers in front. Then you multiply the radicands, the numbers under the radicals. Under radicals. And then lastly, you simplify if necessary. Sometimes you don't need to simplify. Sometimes you do need to simplify. Right? So the big thing, though, is when you're multiplying radical expressions, once you're out of the radical, you don't want to go back in. So numbers out of the radical, multiply by numbers out of the radical. Numbers in the radicals, multiply by numbers in the radicals. Again, once you're out, you don't want to go back in. So let's take a look here. We have root 6 times root 6. Right? Root 6 times root 6. Well, we only have numbers under the radical. So we're going to take the 6 times the 6, and we're going to multiply it. Well, 6 times 6 is 36. The radical comes back into play. Well, here's that simplified thing. What is the square root of 36? Well, our answer is 6. Here we have root 2 times root 5. Well, we only have numbers under the radical. Right? We're going to take root 2 times root 5 is going to give us root 10. All right, factors of 10 are 2 and 5 and 1 and 10. None of those are perfect roots, so we're done. And last one, we have 4 root 5 times root 11. Well, we have a 4, and we have, remember this imaginary 1 right here. Well, it's not imaginary, it's invisible. So we have 4 times 1, which is 4. And then we have the 5 and the 11 are under the radical. Multiply those together, and you get 55. And then we think, all right, are there any factors of 55 that are perfect roots? Well, there's 5 and 11. None of those are perfect roots. And we have 55 and 1. None of those are perfect roots. So we're done. 4 root 55. And this last one, let's go red. We haven't used red in a while. All right. So we have negative 2 times 5. We multiply outside the radicals. Negative 2 times 5 is negative 10. And then we have under the radical, we have a 3 and a 6. So 3 times 6 is 18. So we got negative 10 root 18. Remember, always check. Now let's see here. Can the radical be split? Is 18 a perfect root? No. Does 18 have factors that are perfect roots? Well, if we list out our factors of 18, if we list them out, we got 1 and 18. We got 2 and 9. And we got 3 and 6. Well, 9's a perfect root. So we can split 18 up into, so now we can rewrite this as negative 10 times the square root of 9 times 2. Right? Well, square root of 9 is 3. So we have negative 10 times 3 times root 2. Well, negative 10 times 3 is negative 30. And then the root 2 stays in there. So this simplifies. The simplified version of this is negative 30 root 2. So remember, the big thing is once you're out of the radical, you don't want to go back in. Okay? So numbers outside, multiply by numbers outside. Numbers inside, multiply by numbers inside. And then always check to see if you can simplify. Biggest thing is know your factors. And then for a monomial times a binomial, we use the wonderful world of distribution, okay, or the distributive property. All right. Again, my favorite property, just because it's used all the time. All right, distributive property. It's one of those ones. Make sure you understand it because again, it's all over the place. You'll always use the distributive property. All right, so let's look here. So here I have a monomial. I have root 3, and I need to multiply it by this binomial 8 and root 5. So I'm going to use my distributive property. I'm going to draw my rainbow. Love drawing my rainbows. So I have root 3 times 8. Well, the 3 is under the radical. The 8's not under the radical. So I'm not going to take 3 times 8. I'm just going to literally put it as 8 root 3 because that tells me 8 times 3. Right? Plus, well, 3 and 5 are both under radicals, so I do multiply them together. 3 times 5 is 15. And we're done. Because 15 can't be split up, okay? 1, 15, 5, and 3, none of those are perfect roots. All right? So that one's done. Now let's look at this one. 2 root 6 times 3 root 5 times negative root 7, right? Our rainbows here. This one we have a 2 and a 3. We're going to multiply those together to get 6. We have a 6 and a 5 under the radical. We're going to multiply those together to get 30. We have a 2 and there's a 1 here, so that's going to be negative 2. We have a 6 and a 7. Those are both under the radical, so that's going to be root 42. So we have 6 root 30 minus 2 root 42. Well, let's see here. If we figure out our factors of 30, right? We got 1 and 30. None of those are perfect roots. We got 2 and 15. None of those are perfect roots. We got 3 and 10. None of those are perfect roots. Then we got 5 and 6. None of those are perfect roots. So we can't split 30. Let's look at 42. 42, we got 1 and 42. We got 2 and 21. So far, no perfect roots. We got 3 and 14. None of those are perfect roots. Right? Nope, 4 can't go into it. 5 can't go into it. 6 can go into it. 6 and 7. None of those are perfect roots. So this is a funny one. All right, we got 2 even numbers under the radicals, but they can't be split. So we have 6 root 30 minus 2 root 42. All right, so sorry, I had a yawn there. What we are doing here is we are multiplying and adding and subtracting. Biggest thing with multiplying. If you're out of the radical, you don't want to go back in. So you only multiply out of numbers by out of numbers. Inner numbers go by inner numbers. When you're combining like terms, when you're adding and subtracting your radicals, only add or subtract the coefficients of the like terms.